Hello and welcome back. Today we're going to be representing data. First one we're going to learn about is a dot plot. One way to represent data is by using a dot plot, which is a diagram that shows the frequency of data on a number line. To make a dot plot, write the data points in order from least to greatest. Hey, Desmos is going to help us with that. Make a number line that starts from the least data point and ends at the greatest data point. Plot the dots on the number line. Stack the points where there's more than one data point with the same number. If appropriate, include a label for the number line and a title for the dot plot. So to start, it says represent the data as a dot plot. Write the data points in order from least to greatest. They started, we're not quite sure everything we're missing, so let's cross things out. We have a 9, we have an 11, we have 2 12s, 12, 12, 2 13s, 13, 13. We have a 14, 2, 3, 4 15s. All right. With that taken care of, let's see what is left. After 9, there's another 11. Then looks like we have another 12, another 13, and another 15. The data are whole numbers ranging from 9 to 15. So make a number line that starts at 9 with intervals of, let's just do 1. Plot the data. All right, so we have a 9. We have no 10s, 2 11s, 1, 2, 3 12s, 1, 2, 3 13s, a 14, and 5 15s. If appropriate, include a label for the number line and a title for the dots. This is just number data, so we don't really have labels. Because no information is given regarding these data sets, no title is needed. All right. Think about it. What would be the benefit of representing data in a dot plot? Well, just taking a look, it's very easy to say your mode. The tallest tower will always be your mode because it has the most occurring values. Also gives you an idea of where your numbers line. We see that quite a few data points are between 11 and 13. Accuracy. Count the listed data and check that the number of data points matches the sum of the frequency table. Missing just one or two pieces of data changes the value of the statistics. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All accounted for. Next page. Represent the data on a dot plot. Now, what we can do is we can fill this in with our dots as we're doing this to help sort it. So I'm going to put an 8, a 6, a 0, a 2, a 7, a 1, an 8, a 1, a 4, an 8, a 0, a 1, a 2, an 8, a 4, a 7, a 1, a 5, a 9, and a 1. There we go. Make a dot plot by using a scaled number line. All right, and this is where the gaps are going to mean different things. So the data show internet usage from Middle Eastern countries as a percentage of their total population. Represent the data as a dot plot. All right, well, let's cross out the values we've already used. So we have 28.1, 57.2, 64.6, 65.9, 74.7, 78.7, 80.4, 86.1, 91.9, 96.4. All right. So let's see, we're going to have 22.6 as our starting point. Then after that, our next lowest will be 33.0. We need 78.6 and 93.2. Make a number line. All right, they've made our number line down here. It says the data range from 22.6 to 96.4. Since these data represents a broad range with specific values, it is unlikely that any data point is represented more than once. To represent the data in a meaningful way, it wants us to scale the number line. And all that means is that we're going to put everything as a range. All right. So now from 20 to 29.9 go here, 30 to 39.9 here, 40 to 49.9 here, and so on. We're getting closer into that histogram territory. All right, because the dot plot is more like a box chart. This right here is just more like a histogram. So for the ones that go to the 20s, we have 2 that go through 20. 1 that goes in our 30 range, nothing in the 40s. We have 1 in the 50s, 2 in the 60s, 3 in the 70s, 2 in the 80s, and 2 in the 90s. It says if appropriate, include a label for the number line and the title for the dot plot. They did that for us. Internet usage from Middle Eastern countries and percentage of population. Think about it. How would these data appear if the number line were scaled by 1 instead of 10? Do you think a scale of 1 would be a good way to represent this data? Absolutely not. It would be drawn out. Everything would only have a singular value. Or just 1. Also, these are decimals, so whole values kind of make it harder. All right. The data give the elevation of the highest mountain peaks in the United States. Create a dot plot to represent this data. All right. Now they're giving us our range, so we can just start filling in data automatically. So this is 20 to 21,000. So we got one right there. We have one in the 18 range. 17. Oh, you see the 17 is not marked, but we have to understand it's there. This goes 14 to 15, with that being 15, 16,000 to 17. So with that there, we have to put a dot there. We have another one in the 16s. 16, 16, 15, 14, 14, 14. That's it. Bar graphs and histograms. Now, like I was saying with the histogram, notice that this one has a range. Histograms are a lot like these scaled ones where they cover a range of things, where bar graphs is more like a regular dot plot. So the two of them that we have bar graph and histograms. A bar graph is a graphical display that compares categories of data using bars at different heights. Bar graphs are used when data are discrete to indicate there is a space between each data point. Histogram is a graphical display that uses bars to display numerical data that have been organized in equal intervals. A histogram represents continuous data, so the bins have no spaces between them. Making one. Determine whether the data should be represented in a bar graph or histogram, and that's really are you tracking the individual values or is there some range that you're looking for? Determine the appropriate categories or bins and tally the data if necessary. Draw bars to represent each category or bin. Label the axis if appropriate. Include a title for the graph. The table shows the total number of Olympic medals won by U.S. athletes competing in select events from the first Summer Olympics in 1896 through 2012. Make a graph of the data to show the total medals won for each sport. So, our task, describe the task in your own words and list any questions you have. How can you find the answer? All right, so the task we have here, make a graph? Make a graph to display data. And it wants total medals. Since we're doing totals here, there's not really discrete or any, talking about discrete and continuous. This is a finite amount, so that would be discrete. So we're going to make a bar graph. How will you approach the task? What have you learned you can use to help you complete this task? Summation. Bar graphs. All right. Now, let's grab our handy dandy calculator. 49 plus 23 plus 39. So the total number of boxing medals is 111. Diving, 48 plus 41 plus 43. That's 132. Swimming, 230 plus 164 plus 126. We get 520. Track and field, 319 plus 247 plus 193. 759. And then wrestling, we have 52 plus 43 plus 34. 129. All right. Now, we're going to make our box chart. So what we want to do is pick each one and make a box. So for boxing, we have 111. Here is 100. It's probably going to be just a little bit above that. So if that's 150, let's say probably about right here. After that, let's go diving, 132. That's going to be higher. Probably closer to the middle of that because it's past the 120 mark. And again, we're making these by hand. Next up, 520 for swimming. So here's 500. There's about 520. Track and field, 759. So that's all the way up here. And finally, wrestling with 129. And there you go. Moving right along. How can you know that your solution is reasonable? Write an argument that can be used to defend your solution. It displays the total. The bar graph displays the discrete medal winnings of the USA with a bar graph. And we were asked to display the data, so we are displaying the data. It's discrete, so we're using a bar graph. All right. Video games. The table shows the number of active video game players in each country. Make a graph that displays this data. All right. So Australia, we have 9.5, and that's in millions. So if that's 20, so we have to check what our bars are. We have 9.5. So this is 20. So 9.5 is about 10. So it goes like this. Next up, Brazil, 40.2. All right. A little bit at that 40. France, 25.3. So here's 20, so a little bit higher than that. Germany is a little bit below that. Italy, 18, so that's going to be below the 20. Poland is at 11. Spain is at 17. Turkey is a little bit over the 20. United Kingdom's at 33. And the United States is at 157. This bar graph clearly shows the United States has quite a few more people that play. All right, determine the appropriate graph for continuous data. Histogram. Marathon. The results of the top finishers of the 2015 New York City Marathon wheelchair division are given below. Determine whether the data are discrete or continuous, then make a graph. Well, these are times. We have a bunch of times at 1:30, and we have different seconds. So yeah, this is continuous data. Clock's running, and we're just taking it in as they come. Because the racers finish within any time, the data are continuous. So we can use a histogram. On to the next page. Because the data are spread over several minutes, group the data by the minute, then tally each interval. All right, so don't you love when they put your data like this? All right, so give me 1 second. Grab a copy. All right, we got a second copy. Now we can fill this out. All right, so it looks like the first thing we are doing is measuring the frequency of people that finished in the 1 minute to the 1:30 to 1:31. So going across their line, I have a 54, a 55, a 134, a 135, another 135, a third 135, a fourth 135, 36, another 36, a 38, a 39, another 39, two more 39s, a 40, and a 43. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2, 3, 4, 5, 6, 7, 8. 8 by 2 is 16. All right, we have our data. Draw a bar to represent each bin. Label the axis to include a title for the graph. All right, so here they did the bars for us. So over here, this is the frequency. This is time. HMS. And we'll call this run times. Photo sharing. The table shows the user of a photo sharing app by age group. Make a graph that best displays the data. All right, so we see that we have a range down here. So because they're giving us a range, we're going to go with histogram. So for the 18 to 24 range, there were 45. All right. Uh, 45 goes to here. There. Next up is 26. After that is 13. After that is 10 for 45 to 54. After that we have 6. And then the 65 plus we have all of 1. Then in the think about it, asks us to describe the histogram. What does it tell us about, for the one above, asks us what does it tell us about the times? Most people, well, if we take a look, most people finished with, let's see, I'd say, yeah, we had 9 people finish between a minute and 34 and a minute 36. Then we had another 5 people finish after that. So I would honestly say most people finish between this time frame, just because it's where most of the data lies. Down here, it's younger people share more photos. That's it. Thank you so much. Have a wonderful day.